Thank you, Sarah. Hi, my name is Amanda Rueda, and today I'll be presenting my thesis research on a novel approach revealing the spatial characteristics of Sounders gray whale foraging in northern Puget Sound, Washington. And this was done in collaboration with Cascadia Research Collective. There are two living populations of gray whales, both found in the Pacific Ocean, the Western North Pacific and Eastern North Pacific population. And today we'll be specifically discussing the Eastern North Pacific or ENP population, which breed and reproduce along the warm sheltered lagoons around Baja California Sur, Mexico, and migrate over 10,000 miles north annually to forage in the North Bering, Chukchi, and Beaufort Seas. This migration is one of the longest out of any mammals. So these gray whales rely on an abundant source of prey in these Arctic seas, particularly benthic amphipods. And gray whales are able to consume massive amounts of these benthic amphipods in the Arctic seas, which are able to support them along their migration south and throughout the winter. However, gray whales are also capable of consuming prey along their migratory route from the Arctic seas down to Mexico. Gray whales are known as opportunistic and generalist feeders, and they are actually known to consume up to 80 different species of prey along their migration route, using a variety of different strategies from skimming, lunging, but they're most known for their benthic suction feeding. Commercial whaling depleted this population by the early 1900s, along with many other large whale species. But the Eastern North Pacific population of gray whales are considered unique in that they were able to make almost a full recovery, and they were delisted from the Endangered Species Act by 1994. However, we've seen these large fluctuations in population abundance in the gray whale population over the last several decades, which are combined with these peaks in gray whale strandings. And we can see just a glimpse of that from this figure here that shows strandings in Washington. There have been two officially declared unusual mortality events, or UMEs, first beginning in 1999 and then 2019. And we also believe there was an unofficial UME that occurred beginning in 1987. And so again, these peaks and strandings are just a glimpse here in Washington where up to 35 whales were stranding a year. But along the greater US West Coast, there were hundreds of whales that were stranding and many more hundreds of whales that were experiencing mortality that we couldn't see underneath the water. And more recently, these 15 to 25% depletions in population abundance have been linked to altering prey dynamics in the Arctic from climate change. So what we witnessed firsthand are whales washing up ashore like the one on the right in poor body conditions. And this whale actually stranded in April of this year. And unfortunately, there's rising concern for the beginning of another UME period, as this was one of 7 gray whales which have already stranded as of April of this year. Uniquely, during these periods of unusual mortality, Cascadia Research has documented a growing number of individual gray whales from the Eastern North Pacific population, which are stopping over in northern Puget Sound to forage for extended months at a time before continuing north for feeding in the Arctic. So we can see from this sightings figure on the right with the unusual mortality periods outlined in rectangles that with the first unofficial UME, there were 6 individuals that came in and started utilizing northern Puget Sound to forage. By the next UME, we saw an increase in 5 more individuals that were documented coming over and using these waters. And then by the last official UME, there were 6 more individuals that were using these Puget Sound waters. We can also see from this figure with the darkening sightings data points that these individuals are also being seen more consistently throughout a season as time goes on. And these identification photos on the left are an example of how we recognize these animals over time based on their markings. And this specific animal is CRC number 21, or Shackleton, which was one of the first identified Sounders gray whales, as we lovingly call them. And again, these whales are detouring from their normal migratory route, which would be shown in yellow here. They're going right through the Strait of Juan de Fuca, around the bottom of Whidbey Island, and then foraging in that shaded white area before continuing north to the Arctic. And so what is bringing these whales into northern Puget Sound waters? As I mentioned earlier, these whales are most known for their benthic suction feeding strategy. And in northern Puget Sound, Sounders gray whales exhibit a high-risk version of this strategy. So we can see in this amazing footage from Hannah Clayton, this animal is going into the intertidal region during high tide in waters only 2 to 3 meters. You can see its pectoral fin isn't even covered fully in the water, and it turns on its side to feed by opening its mouth, and that creates a large suction, capturing large amounts of sediment, water, and prey. And then you could also see it uses its baleen plates to filter their prey from that sediment and water. And you could see the mud plume that had emerged during this strategy. Then as the tide goes out, hundreds to thousands of visible depressions in the sediment are visible, which are called feeding pits. And that's what we will be focusing on for today's study. And then taking a closer look at an individual feeding pit, you would see many burrow openings, which are home to the ghost shrimp and estuarine burrowing shrimp that are highly abundant in the Pacific Northwest and along the West Coast. Our goal for this study was to quantify the extent and spatial characteristics of Sounders gray whale foraging in northern Puget Sound. Cascadia Research Collective conducted 19 aerial surveys on a monthly basis between the months of March and July from 2017 to 2024. With thanks to Fred Lundahl and Julia Erickson, our pilot and photographer. And I was able to examine thousands of photos like the one on the bottom left and identify feeding pits that were present in the intertidal region. And then I used Google Earth Pro to hand draw polygon shapes around these feeding pit areas. And I ended up creating 1,089 polygons by hand. 83 of these polygons were removed because the feeding pits appeared to be weathered due to tidal action. And we were only interested in those fresher pits to show fresh feeding each month. So we added those remaining polygons to get our response variable, which was total feeding area. And we also identified 8 regions within northern Puget Sound to see that those regional feeding changes over time. And so this map shows the areas of feeding throughout the study period from 2017 to 2024. We also were able to quantify the maximum feeding area extent. So this value shows everywhere where feeding was capable in northern Puget Sound from the study time. And this value was almost 14 square kilometers. 38% of this value was found near the Snohomish River Delta, and 31% was found north of the Tulalip Reservation and going into Port Susan Bay. Then we also found 3.25 plus or minus 1.59 square kilometers in average feeding area per survey. And so that shows that there was quite a lot of variation in feeding area observed in each survey. So to take a closer look at that, we can see with our figures on the left that it appears that region and month might have had an influence on the average feeding area that we saw. We can also see on the right in the blue that the number of Sounders gray whales sighted in northern Puget Sound increases throughout a season up into May. And then that's when those Sounders begin departing and continuing to the Arctic seas. And there's a similar pattern in average feeding area by month, where the feeding area increases throughout the season. There's a slight lag in June where feeding is still observed, and then it ends up decreasing in July. Going back to our average feeding area by region, we can see that the Snohomish River Delta had the greatest amount of average feeding area across all months compared to other regions, followed by north of Tulalip, southwest Camino, and east Camino, where there was also a spike in June, which we also saw in northeast Whidbey. But for the most part, these regions, along with the other 4 regions on this figure B, with the different y-axis to show variation in month, those all remained under 0.4 square kilometers, with southeast Whidbey, Holmes Harbor, and northwest Camino. Then to take an even closer look at the variation in feeding area by survey, we fit a series of generalized linear mixed models. And before model selection, we tested for multicollinearity using Pearson's coefficients. All of these values were below positive or negative 0.5, so that indicated a low chance of collinearity. And then we also scaled our response variable, which was total feeding area, that was originally in meters squared, and analysis was done in square kilometers. We used AICC model selection to rank 13 candidate models. And the selected model had whales and mean tidal height both included as fixed effects. Other variables considered were month, year, and observed regions, which is a variable that represents a value from 1 to 8. And that indicates the amount of regions that were captured in a given survey, and that accounts for differences in survey coverage. So our selected model had a R-square value of 0.59, which indicates the model accounts for 59% of the variance in total feeding area. Looking at these effects plots, we can take a better look at our individual variables. Both of these p-values indicate they were statistically significant. Number of gray whales had a positive effect on total feeding area as expected with more animals in a region. And mean tidal height had a negative effect on feeding area, which was likely because of feeding pits being covered by water. Using our whale presence coefficient from the model, we estimate that each incoming Sounders gray whale is contributing to 2.28 square kilometers in total feeding area, which is double the size of Capitol Lake in Olympia, Washington. And we can also see from the map on the right showing the Snohomish River Delta that over this 8-year period, these regions were consistently utilized, as we can see those overlapping polygons over time. And so this information is important to pass along to regional managers, including Department of Natural Resources, which manage a ghost shrimp fishery, where ghost shrimp are harvested in many similar locations where gray whales forage in these regions, and also to notify vessel traffic, as this area is just north of the Everett Marina and of the Clinton-Mukilteo Ferry, and gray whales are highly susceptible to vessel collisions as they're coastal foragers. It's important to mention some limitations of this study. First, survey coverage did vary by region and month. And we also found in our model that tide had an effect on the amount of feeding that was captured in a survey. And as I mentioned, this is likely due to water coverage, as you can see from the image on the bottom left. This is right by Jetty Island, where normally there would be hundreds of feeding pits, but it's covered by the tide in this photo. However, this remains the first quantification of maximum foraging area of Sounders gray whales in a time where prey consumption and habitat use is critical for the conservation of the species. And we're excited to continue studying certain aspects of this research, including weathering of individual feeding pits and feeding pit densities within a given area. And these different metrics can play hand in hand with prey consumption and energetics research that Hannah Clayton is conducting right now in her 3rd year of her PhD at Stanford. Thank you again to Fred and Julia for conducting our aerial surveys. We couldn't have done this without you. Thank you to Cascadia Research Collective for letting me work on this project and for supporting me, specifically Alex Vandersee, John Kalambokidis and Hannah Clayton. Thank you to my parents and family. This is my grandfather here on the bottom right. He was a fisherman and vessel mechanic near one of the breeding lagoons in Guerrero Negro, and he dedicated a great portion of his life to conserving one of these breeding lagoons and had a very close relationship with these whales. So I like to imagine that the individuals up here could be also some of the ones that he knew. Thank you, everyone, for coming, and I'll leave you with this photo of seabirds by some feeding pits. Thank you.